For
This
everybody.
conference will now be recorded.
And thanks for joining last month and also providing feedback in the meantime, which helped us really be able to hone this presentation and to develop in a way we feel it's more meaningful to you. So, just very quickly, you all can put comments in the chat box, and I'll stop periodically to ask if there are any questions verbally as well. So as we begin, we'd just like to introduce the pilot a little bit more toward modernizing drought early warning in the United States. Our vision here is really for building drought resilience for our nation's economic sectors. And we'll do so by informing early warning decision making based on co-developed sector-specific and evidence-based drought intelligence. The co-development of this drought intelligence is really key, which is why we've decided to do this pilot in a sort of small fashion so that we can interact with you all to be able to really hone our chops and to be able to make something that's meaningful to users of information like you all. And then the process that we're following is we're delivering monthly sector-specific drought scenarios based on integrated and tailored monitoring and forecasting information. Our pilot is taking place over Southern California, and the counties that we're including here are San Luis Obispo, Santa Barbara, Ventura, Los Angeles, San Bernardino, Orange, Riverside, San Diego, and Imperial. More or less all of Southern California except Kern County. We do this in the context of what is happening over the larger southwestern United States region because the water resources within Southern California are intimately tied in with the Southwest. So we do put this in the context in Southern California within the context of the Southwest United States. The timeline is as follows. So we have gone through this exercise once before at the end of October, and here we are doing it for a second time at the end of November and early December. So what we do is we send out a solicitation that Amanda sends about a week prior to when we'll commence these activities and provide the drought outlook briefing. And then the following day, after the drought briefing, we provide a summary. So the summary information may be found tomorrow, where you can find the recording of this presentation. You can find a summary document and hopefully be able to use that information. We'll be performing these activities several more times during the Southern California wet season. That will be toward the end of January, toward the end of February, toward the end of March and early April, hopefully to capture the end of April water year in terms of snow water equivalent, which is key to the water resources in the Southwest, which is why we're commencing on those dates. And then finally, once again, toward the end of April and early May. Now, the sector-specific drought briefing follows the following format. The first, we provide a global perspective where we're really honing in on conditions that are relevant to Southern California sectors, and most prominently the El Nino Southern Oscillation. Second, we provide a regional perspective where we look at Southwest United States conditions that are relevant to the Southern California sectors. And then finally, we'll get into the sector-specific drought outlooks where we'll provide the scenarios based on the evidence that we have at hand. And those include water utilities, agriculture, and public health. We have three lines of evidence for developing these sector-specific scenarios. The first are observed conditions. It's really the current state of the region from observations as of this morning, December 5th, 2024 at 10 a.m. Pacific time. We're using predictions, of course, and those are based on expert interpretation of many different types of forecasts so we can anticipate what the future may hold. And then finally, end of season outcomes we're doing here. And this is a little bit of a new perspective, and I'll describe it in more detail in the following slide. The purpose here is to use a combination of season to date conditions, observations, and similar historical periods to project chances of future outcomes. So how do we do this? Well, with end of season outcomes, what we do is we take conditions to date, and they're the most recent observed estimates. So for conditions that we have through the 4th of December, so yesterday. What we then do is we then create two scenarios. The first is that we take all conditions to date through the 4th, and then take all the seasons and then put them together with the observed conditions, and then try to constrain the possible outcomes, the chances of October to May outcomes based on those conditions to date and the rest of the season. We also provide a second scenario here, and that is by taking conditions to date and then only including the years in which we don't have an El Nino since 2000. The reason why we do that is because this year we anticipate ENSO neutral to La Nina conditions, and since 2000 because we want to be in a more modern climate that tends to be warmer than those of the past. So here is what these end of season outcomes look like, and you'll see perspectives like this throughout the entirety of the presentation. So on the left, what this does here is it takes conditions through the 4th of December, then takes all of the seasons since 1979 and combines them, and then calculates the likelihood of seeing precipitation in the lower 33rd percentile, which is below average, or the upper 66th percentile, which is above average. And as you can see here, just based on where we've started the season, which has been dry, we're tilting the odds to seeing below average precipitation in Southern California and the Southwest United States because of that start to the season with low precipitation. Then doing the same perspective, but only including years where we didn't have an El Nino, we tend to have greater odds of below average precipitation. It makes sense because that tends to be the situation that we see when we see no El Nino years, that is below average precipitation. And again, you'll see that quite a bit as we move through the presentation. One more thing here is in interpreting sector-specific scenarios, high confidence for us means close agreement among several robust sources of evidence. Medium confidence means modest agreement among several robust sources of evidence. And then finally, low confidence. We just don't have much agreement among all the sources of evidence that we have at hand. So before I get into the remainder of the presentation, are there any comments or questions that people might have? And again, you can put that in the chat box as well. All right, well, hearing none, let's move on here to the global perspective where we set the stage for
Hey, Andy,
conditions. Yes.
can I pause you for just a moment? I think Joel might have a question.
Okay, go ahead, Joel.
Thanks, Eleanor. We're sharing an office, and I was like, "How do I type so fast?" And I couldn't type. Anyway, hey, when you say no El Nino, does that mean ENSO neutral years specifically, or does that mean La Ninas and ENSO neutral years?
Yeah, it means La Nina is an ENSO neutral.
Okay, that's my only question. Thanks, Andy.
Thank you, Joel. Yeah, the benefits of sharing an office. All right, we'll move on here to the global perspective to again set the stage for conditions within the region.
Hey,
So,
Andy, it looks like we've got another one from the audience.
oh, sure, go ahead.
Hi, this is Rakesh. So when you say outcomes, that refers to the probability of precipitation below, higher or lower than average. Am I
That's
getting
correct.
it?
That's correct. In that context, that's what we're looking at is seasonal precipitation through the end of May being above or below average. We'll also use the same perspective for other quantities as well. We'll be looking at seasonal temperatures. We'll be looking at the chances of precipitation days and also the chances for temperatures below 32 degrees on any given day. So we'll be using that perspective in several ways and just trying to illustrate it with that end of season precipitation outcome.
Thank you.
Now, thank you for the question. All right, so with our key takeaways, the El Nino Southern Oscillation. El Nino Southern Oscillation is composed of three phases, El Nino, La Nina, and ENSO neutral, which are all related to weather and climate anomalies that we use to predict conditions over California, months to seasons in the future. The most likely situation is that a La Nina is forecast to develop in late 2024 and persist into early 2025. And that tilts the odds and increases the chances for below average precipitation in Southern California. Now, this is a picture that is put together by NOAAclimate.gov and nice and succinctly places into context conditions that we tend to see during La Nina events. That is, over the Southwest United States and Southern California, we tend to see drier than average conditions. That is, below average precipitation through the end of the winter wet season in that part of the world. Now, where we stand with the El Nino Southern Oscillation right now is that we see neutral conditions. So the El Nino Southern Oscillation can be measured in several different ways. A very simple way to do so is by measuring sea surface temperature departures from average over the central tropical Pacific Ocean. And what we're seeing here in the latest trace is that conditions are near average in terms of sea surface temperatures. That is, we have not seen the emergence of a La Nina that has been forecast for several months. And this has been an unfortunate situation because this forecast really hasn't played out. Now, in terms of the forecast that was made as of a few weeks ago, there was still an indication at the time that there would be a La Nina event that would develop, a weak La Nina event that would develop by the end of the calendar year and persist into early next year. And that's what's being shown here. So the likelihoods of a La Nina being observed early next year were to the order of over 60%. And even in November, December, January, and December, January, February, what we saw there was a forecast probability of greater than 70%. So that hasn't materialized thus far, and we are being very vigilant in watching this situation because there is a chance that a La Nina event will not happen. Now, in terms of another important aspect of the global climate that affects Southern California is the Madden-Julian Oscillation. So what it is, it's composed of 8 phases that are related to weather and climate anomalies that are used to predict conditions in California several weeks into the future. And like what happened the last time we did these drought outlooks, we do have a Madden-Julian Oscillation event that is underway. And we'll move into a phase, the 6th phase, that decreases the chances of a precipitation event in California during the first 3 weeks of December. So the Madden-Julian Oscillation in its most simple form can be looked at as an area of enhanced precipitation and suppressed precipitation in the tropical Pacific and Indian and Pacific Oceans. And it moves eastward like so. So you basically get this couplet of below average precipitation and above average precipitation that moves to the east. What that couplet of below average and above average precipitation does is it ends up perturbing the atmosphere in such a way where it just sends off waves across the North Pacific Ocean that can change the storm track and divert storms in different trajectories than they otherwise would be. So the phase that we're anticipating for the Madden-Julian Oscillation is phase 6 over the next few weeks. And what that tends to do is it decreases atmospheric river activity and storm activity across the West Coast in Southern California. So that right there will be reflected in the forecast and is something that we do have a little bit of confidence in. Now, I'll get into the regional perspective, and then I'll ask if our audience has questions after I finish this part of the presentation. So where we stand right now is, in terms of our current drought, considerable area in the Southwest US and Southern California is in drought and has been since the summer of 2024. The reason for that is we saw below average precipitation during the North American monsoon season. And we've also seen below average precipitation since the beginning of the wet season, the winter wet season that spans 2024 to 2025. So this is since October 1. This has worsened drought conditions. Another point here is that reservoir levels remain near and above average. And that's a nice thing because it happens to add a buffer to the situation that we're in if we see below average precipitation. But groundwater remains low in areas due to decades of drought and pumping. So this right here is the US Drought Monitor. So the US Drought Monitor right now is depicting widespread intense drought in Southern California and the Southwest United States. And I'm referring here to the plot on the left, which categorizes drought as abnormally dry, moderate drought, severe drought, extreme drought, and exceptional drought. The US Drought Monitor is a nice tool for looking at broad scale conditions. It's an aggregate product where humans, they look at all the evidence at hand and they're able to make a determination about what is going on in the drought situation. It doesn't have to apply to every given situation, and sometimes it probably isn't the best application of it. But for our purposes here, it's a nice application because it gives us a general sense of what is happening in the drought space in the Southwest. And as we can see in Southern California and Arizona, in the general Southwest, there are widespread drought conditions with some extreme drought along the border of southeastern California, Arizona, and Nevada. Now, where we've been since about 6 weeks ago, that's comparing December 3rd to October 22nd, that's here on the right, we've seen drought deepen at least a little bit in terms of a one-class degradation over several areas, whereas in these gray areas indicate there really hasn't been too much of a change. One thing to note here is that in other areas of California, for those who may be interested in coastal California, the Bay Area, and to the north, there has been a removal of drought there. And the reason for that is because of a precipitation event that we saw last week. Now, this is soil moisture. So what this product does here is it simulates soil moisture within the first meter of the soils. And what it does there is it puts it into a historical context and calculates the percentile rank. So values that are less than about 20%, they're indicating drought. You see that widespread across Southern California, Arizona, and parts of the Southwest United States. So that's really keying in on drought there. And these are conditions, the latest conditions as of November 30th. Now, unfortunately, precipitation since the beginning of the water year, the beginning of this wet season, since October 1st, has been below average. And though that plot right there should say December 4th. So these are conditions through December 4th. What this indicates here is that precipitation percent of average is less than 25 across all of Southern California, Southwest Arizona, and Southern Nevada. And in terms of a percentile rank, so essentially ranking this season in the season thus far to other such seasons in the past since 1979, we're seeing percentile ranks that are in the lower 10%. So as a result of low precipitation or lack of storms coming through the region, we've seen low precipitation. Now, at the same time, we've seen above average temperatures. So these are temperatures across the Southwest United States for maximum temperature departures from average. And we can see that for the most part, we're seeing temperature departures on the broad scale of about 1 degree Celsius departure from average. So 1 degree Celsius above average. In terms of percentile ranks, this ranks in the upper third to upper quintile of the historical record that dates back to about 1979. One thing that I do want to note here is that we're using gridded data sets for this perspective. So what gridded data sets do is they take measures of data that we have, whether they're from stations or satellite estimates, and it nicely organizes that data into grids. Now, when it's nicely organized into grids, what can happen is sometimes there can be artifacts, and those artifacts can be seen here in terms of temperatures over eastern Arizona and even parts here along the coast of California. So gridded data sets are of value to us because they allow us to be able to interpret the situation, but they're not perfect. And I think we're seeing some evidence of that here. Now, in terms of snowpack, so the amount of water in the snow on the ground is very important to Southern California and the Southwest more generally. What this is showing here is a percent of median snow water equivalent as of a few days ago, the 2nd of December. And what it depicts is that through most of California through this period, we're seeing very high snow water equivalent values, lower such values in much of the Southwest. Now, this right here is just because of 2 storms in recent weeks that have come through the region. We have a long way to go in terms of building the snowpack in the Southwest United States. So just because we're seeing values here that may be above average or below average, that in and of itself isn't necessarily too much of a concern because there's a long way to go to the wet season and there's a lot of snow accumulation that has to happen. Now, in terms of water resources on the ground, reservoir storage is generally above average across Southern California, the Southwest United States. Now, that is as a result of some really exceptional precipitation that we've seen in the prior 2 wet seasons. And this helps to buffer when we have a below average precipitation year. In terms of groundwater, the same perspective, not quite the same perspective as reservoirs. We're seeing pretty low groundwater across a lot of Southern California and even other parts of California as well. The reason for that is because there's been quite a bit of pumping, and that pumping is because of several decades of drought that have led up to the last couple of years. And we just haven't been able to see the recharge that has been, that we've needed. Now, Annie's asking a question, what source are you using for the gridded temperature and precipitation data? This is from a data set that's created by the Climate Prediction Center. And the reason why we use that data set is because it really updates in near real time. So the latest updates are of the 4th of December. There are other data sets that can be used, gridded data sets. Unfortunately, for our purposes, they don't update in real time and quick enough for us to be able to make that rapid assessment. Now, in terms of forecast relevance of drought, these are generally based on forecasts that are coming from NOAA's Climate Prediction Center. So the first point here is that drought is expected to persist in the southwest US through the end of February 25, according to NOAA CPC. Two, forecasts indicate increased chances of below average precipitation through May of 2025 in the southwest. And then finally, forecasts indicate that above average temperatures are most likely across the southwest through May of 2025. What's being shown here is the drought outlook that's valid from November 21st of 2024 through February 28th of 2025. And this was released on the 21st of November of this year. And what it indicates is that drought is expected to persist across much of southeastern California and parts of the southwest United States, which include Nevada, Utah, Arizona, and New Mexico as well. Now, in terms of forecasts that are relevant to drought and persistence and really drought and development, these are weeks 3 and 4 precipitation and temperature forecasts. These were made last Friday, and these are the most recent week 3 and 4 forecasts that we have, and they're valid for December 14th to the 27th. And what it indicates is that across a wide area of the Southwest, which includes our area in Southern California, maybe with the exception of Ventura counties, Santa Barbara counties, and San Luis Obispo, that below average precipitation is preferred. Temperatures across the Southwest for the weeks 3 and 4 in the future, not indicating that there was a tilt in the odds to above or below. Now, as we look in terms of seasonal precipitation outlooks, what's shown here on the left is seasonal precipitation that's expected for December 2024 to February 2025. And on the right, this is a forecast for March to May of 2025. Both indicate that the most likely outcome for southeastern California and southwest United States in general is for below average precipitation. A little bit higher confidence for December, January, February. The reason for that is just because it's a shorter lead forecast, and we tend to have a little bit more confidence in terms of those forecasted shorter leads. In terms of temperatures, above average temperatures are most likely in the southwest, and that includes southeastern California as well. So that is just a reality of the situation that we tend to see now in terms of temperatures, is that a more modern climate tends to be warmer than a past climate. Now, before we get into the individual sectors, are there any questions that anyone in the audience might have on what we've covered so far? Okay, so let's move on here to our water utility sector. So where we'll begin with the water utility sector is to present the scenario. So the scenario that we have high confidence in is that reservoir storage and groundwater levels are expected to be lower in October 2025 compared to December 2024, where we stand now. So the supporting evidence that you will see in just a few slides is that we have an increased chances of below average precipitation and above average temperatures in the wet season that spans 2024 and 2025. And that below average snow water equivalent is expected in spring of 2025 because of below average precipitation and above average temperatures. We're also expecting lower groundwater levels to a lower chance of recharge through October 2025 because of forecast below average precipitation in the current wet season amid continued use. And then finally, several areas in Southern California are already reporting low groundwater, and we wouldn't expect that groundwater to increase in its levels. Now, I already showed this picture before, but what it shows is the end of season, that is October 2024 to May of 2025 precipitation chances that are based on observed conditions through the 4th of December. And on the left, all the history that we have since 1979. And on the right, with no El Nino events. So that includes ENSO neutral and La Nina events. So on the left, this is really a measure of taking into account conditions to date and how the conditions to date help to condition a possible outcome toward the end of the season. And because we've seen below average precipitation thus far in Southern California, that helps to tilt the odds to below average precipitation for the entire wet season that spans October 2024 to May of 2025. And you can see this here in terms of a 40 to 50 and perhaps even a higher than up to about a 50 to 60% probability of below average precipitation. Now, looking here on the right, what this does here is it takes into account the observed conditions through the 4th of December, but does not include El Nino years since 2000 as a possible outcome. So the years that are included in this calculation are shown below. These happen to be ENSO neutral and La Nina years. So what you can see here is that the combination of this year and also observed conditions would indicate that below average precipitation is pretty highly likely in Southern California and the Southwest United States. Now, what we do is we take the same perspective, the same infrastructure, and then do the same calculation for maximum temperatures. So what we're seeing here on the left is that above average temperatures are most likely, and then on the right, that including only ENSO neutral and La Nina years, what that indicates is that above average seasonal temperatures are most likely. And these are some pretty high probabilities to the tune of about 60 or 70%. Now, one thing that we do need to consider here, and in future months, we'll be able to do a little bit more rigorous analysis of snow water equivalent just based on data availability, is that when we have La Nina events or conditions that resemble La Nina, like we have in this season, that we tend to have below average snow water equivalent over the western and southwestern United States. And examples are shown here for the years of 2018, 2021, 2022. Now, 2023 was also a La Nina year, but at the same time, we saw above average snow water equivalent on April 1st. It's not to say that we always see below average snow water equivalent in La Nina years or years that resemble La Nina, but we tend to see it more often than we don't. Now, this again is the water utility scenario, and I think this is a good place to pause and ask if there are any questions. All right, well, hearing no questions, let's move on to agriculture. So with agriculture, we are expecting another highly confident scenario in which crop stress, which may reduce agricultural productivity, is expected through spring 2025 in Southern California. The supporting evidence is that below average precipitation in Southern California is most likely due to increases in the number of days without precipitation, that is dry days. Above average seasonal temperatures are most likely in Southern California. But what's interesting here is even though we're anticipating above average seasonal temperatures, we have an increase in the amount of intermittent cold air outbreaks in the United States that leads to below freezing temperatures in Southern California. So this is a little bit of an interesting juxtaposition here, where we can have above average seasonal temperatures across Southern California and the Southwest United States, but we can also have an increase in the number of intermittent cold air outbreaks, and therefore leading to stress in terms on crops. Now, this is a forecast from the NOAA Climate Prediction Center for soil moisture, and it was generated on the 10th of November, and it's valid for November 2024 to April 2025. So what this indicates is what the soil moisture percentile is most likely to be at the end of April 2025, so the 30th of that month. And as you can see in the Southwest United States, there's a preference for low soil moisture across the region, and that includes Southeastern California as well. Now, this map we showed previously, so I'm not going to dwell on it too much, but what we're indicating here is that conditions to date and also playing out conditions toward the end of the season that we would tend to expect, as in no El Nino events, that increases our odds of below average seasonal precipitation. And likewise, that also increases our odds for seeing above average temperatures for the entire season. Now, another perspective to bring in here that is relevant to agriculture is the number of days number of wet days and number of dry days. So what's being shown here is the chances of seeing wet days across Southern California and the Southwest United States based on the perspective that we've been using. So conditions through December 4 and all historical conditions, that leads to a situation where we're expecting to see an increase in the likelihood of the increase in the likelihood of having fewer wet days over Southern California and the Southwest. And likewise, on the right, when we include those no El Nino years, we see an increase in the likelihood, an even higher increase in the likelihood of having no wet or having fewer wet days. So this goes part and parcel with the seasonal precipitation outcome. That is, when we have an increase in the likelihood of below average seasonal precipitation, we also have an increase in the likelihood of the number of dry days, or that is having fewer wet days. Now, the juxtaposition that I was alluding to before is shown right here. And what this shows here are the chances of freezing days. So the chances of having days below 32 degrees Fahrenheit. So the minimum temperature falls below 32 degrees Fahrenheit. So what is shown here are conditions through December 4, and then including all historical years and no El Nino years. So what we're seeing here is an increase in the likelihood of freezing days across Southern California and the Southwest United States. That aligns with our perspective that when we have these La Nina events or something that resembles a La Nina event, that there's an increase in the number of cold air outbreaks across the United States and North America. And that's what we're seeing here. So the conditions that are setting up in terms of El Nino Southern Oscillation would increase our chances of seeing these freezing days across the Southwest and Southern California, which would further increase the likelihood of seeing crop stress across that region. Now, this is the agricultural scenario once again. Are there any questions about the agricultural scenario or the evidence behind it?
Yeah, I have a quick question. I was wondering if you could explain. Oh, sorry, I hear an echo. What is the spatial resolution of the gridded temperature and precipitation data you're using? And then can you clarify how you're defining wet days? Like, is it 0 inches of rain, or is there some like cutoff that you use for that?
Yeah, it's a good question. So in terms of the data sets that are used here, the precipitation data set is a quarter degree, so nominally 25 kilometers. The temperature data set is half a degree, so nominally 50 kilometers, so a pretty coarse resolution. There are other data sets that NOAA has that go down to 4 kilometers. Unfortunately, those data sets, they don't update with as quickly as the data sets that are being shown here that are produced by the Climate Prediction Center. So we could rerun that analysis at a finer resolution with an alternate data set that's also produced by NOAA, but there would be a greater time lag behind that, and we probably wouldn't have the latest conditions that go into it. In terms of precipitation days, those are days in which precipitation exceeds 1 millimeter within that grid point. So it's not a zero. It's hard to actually get a zero on gridded data. So we use 1 millimeter because 1 millimeter is a pretty low value. Does that answer your question, Annie?
Yes, thank you.
Thank you. Okay, well, we'll move on here to the public health scenario, where, and I think this is one area because we had our meeting with public health professionals and representatives a few weeks ago. It was a fantastic meeting, and we were able to get a lot of feedback, and hopefully we can continue that dialogue as we go forward to really tailor some of the perspectives that we're taking to what it is that you need in your decision making. But here for this scenario, intermittent poor air quality is expected during winter and spring 2025 in Southern California due to wildfire smoke and blowing dust, and we have high confidence in that. The supporting evidence here is that in winter and spring 2025, air quality will most likely be reduced by smoke from wildland fires burning in the Southwest. And then finally, in spring 2025, air quality will likely be reduced by airborne particulates due to intermittent strong winds from the north and west blowing over the dry land surface caused by below average precipitation during the 2024 to 2025 wet season. Now, this right here is a map that shows air quality index at given points and also overlays the location of wildfires. This is from this morning, so December 5th of 2024. And as you can see over a very large area of Southern California, that there was unhealthy for sensitive groups air quality across the region. Also, if you wanted to go to the north, you saw the same as well. But this is really outside of our focus zone, but is nonetheless important. You can see that this low air quality was co-located with several fires that are burning in Southern California and also Central California to the north. And unfortunately, because of the slow start to the precipitation season over Southern California, we really haven't seen a way to put out these fires in mass like we would expect. And it just follows that the dry start would lead to fires continuing to burn into the winter season and thus reducing air quality across the region. Now, the increased chances of below average precipitation in Southern California and the Southwest have been pretty well documented, not only from forecasts that are coming from NOAA, NOAA's Climate Prediction Center, but also trying to use analogs in seasons that we think are similar to this one, as is shown right here. Now, another analysis that we were able to do here is to show the average number of days for each month in which we saw winds of greater than 10 miles an hour. So this is based on gridded data and an atmospheric reanalysis. And that gridded data is done at 25 kilometers, about 0.25 degrees resolution, 25 kilometers. And as you can see in March, April, and May, Southern California and the Southwest United States have their greatest incidence of seeing these high wind speeds of greater than 10 miles an hour for a daily average. So this doesn't include gusts. It's just the daily average wind speed of greater than 10 miles per hour. So then what we're able to do here is to show on the left the fraction of days where we see daily wind exceed 10 miles per hour. And this is for March, April, May. And then on the right, this is the same perspective, but for wind speed. So on the right, what we're showing here is the average wind direction on those days in March, April, May, in which we see wind exceeding 10 miles per hour. So there's a fair bit of occurrences in Southern California, Southeastern California, in which we have these windy days, up to the order of about greater than 30% of the days within that season. This is mostly confined here to Southeastern California, but you can also see this as well along the coastal plain, that is San Luis Obispo, and down into Santa Barbara County. Now, for the most part, those areas where we see the higher incidences of these windy days, we tend to see winds that are coming from the west and northwest. This is especially true over southeastern California, but can also be seen here along the coast with San Luis Obispo and Santa Barbara counties. There seems to be a shift in the winds the further away you get from the coast, but these days it really doesn't get too windy either. But it is something to note here that if we did have some wildfires out here that were starting to burn at the beginning of the wildfire season in Southern California, that these winds would be out of the east and then blow it back toward Los Angeles and Ventura counties. So this here is, again, the public health scenario, and I'll open it up to the audience. Are there any comments or questions? All right. Well, hearing none, I think that is that's our final slide. So if there are any other comments or questions from folks, well, we'd love to hear them now. And feedback is important too, if there is any. Well, I suppose, Amanda, I'll hand it back over to you if you have any concluding remarks.
Oh yeah, I was gonna say it's pretty quiet there. And obviously you all know where to find Andy or I for asking any questions, or Ryan, who obviously helped a ton. You may recognize Ryan Harp's name a little bit more than ours from the health folks. with that, as mentioned, I put the stuff in the chat with the link to the webpage where this will all go, but you should get an email tomorrow with the write-up and the recording of this as well as everyone who's on our list. So then you can share that, take a look again, follow up, all kinds of things. And I think our next one, it's in the latter half of January. I can't remember the date off the top of my tip of my tongue, but it's in the latter half of January. Will be the next one of these due to the holidays and things like that. So I think that's all I have. Andy, are you good?
I'm good. Thank you guys very much for coming. And of course, if there's any sort of feedback, we'd love to hear it.
Thank you all.
Thank you.